Okay. Here are the step-by-step instructions for an electrochemistry practice test that I found online from a site called Solero. So when we're going through this, the very first one is some information about rust, and in it, it asks us which entity gains electrons. So when you're taking a look at that, you are picking from your reactants, and you could assign oxidation numbers, like iron by itself is 0, oxygen by itself is 0, and so on. And then just kind of going a little bit faster here, within this compound, we have Fe positive 3, so that would be positive 3, and negative 2. So I know that is really hard to see. But if you are gaining electrons, you are decreasing in oxidation number, and that is why your answer is B from oxygen. So whenever they're asking you what's gaining or losing, just make sure you are picking a reactant, because that is what's reacting. Now this next one is a little bit like a theory question. It's asking about your strongest reducing agent. If this was listed in the data booklet, it would be listed in this order, you know, from cell potentials, because your cell potential starts big and then ends up getting more negative. So when you're reading the table, we know that OAs are on the left-hand side and RAs are on the right-hand side. And if it is listed in order from strongest cell potential to weakest, then your strongest RA starts at the bottom right, and then they get weaker. So when you're reading the table, you just want to make sure you are looking at the product side. So your strongest reducing agent would be A, the V2 positive ion. The next one, so I know these answers are already highlighted, but it's when I did my screenshot. The next one is, which of the following statements about the use of electricity in both voltaic and electrolytic cells is true? So with this one, if you have a voltaic cell, you're a spontaneous reaction, and voltaic cells takes chemical energy, right? The chemical reaction, that's a spontaneous reaction, and turns it into electrical energy. On the other hand, electrolytic cells, right, they're non-spontaneous. So it takes electricity to force a chemical reaction. So it's different in that sense. So the one that works here is C. Voltaic cells produce electricity while electrolytic cells consume. Okay. Moving on to this next one. Here we want to balance, and you can balance with oxidation numbers. So this first one would be 0. Our next one, we know oxygen is always -2, hydrogen positive 1. And then if there's 3 oxygens at -2, that would be -6. So to make this neutral, your nitrogen here has to be positive 5. Here we know hydrogen is always positive 1, chlorine would be -1. Over here, again, hydrogen is always positive 1, chlorine is -1, and the AU has to add to neutralize, so that would be positive 3. Then -2, positive 1, and -2, positive 4. So when we're taking a look at what's changing, you would see that nitrogen is going from positive 5 to positive 4. That's an exchange of 1 electron. Now, AU is going from 0 to positive 3. That's an exchange of 3 electrons. So to balance out electrons, we need to multiply our nitric acid by 3. And luckily, it's just asking for the coefficient in front of the nitric acid, which will stay 3. And then the rest we would end up balancing by inspection. So I'm not going to balance this whole thing because it's not asking for that. It's just asking for the nitric acid, which was there. Now, moving on to this next question, saying which of the following reactions represent the balanced redox reaction involving dichromate and the phosphorus ion in an acidic medium? With this question, when we're taking a look at it, you could start with oxidation numbers, or with everything reacting and then balance from there, or you can start with half reactions. So if I was to take a look at this one, I might just write down what we have reacting. So chromium, which would be with a 2 here, O7. And I actually think when I did this question, I just used the choices to come up with that general reaction, and then I balanced it. So we have plus Fe2 positive, and then we're moving on to hydrogens. And then on the product side, we have chromium 3 positive and the Fe ion and water. Now with this one, I did balance using oxidation numbers. So knowing the oxidation numbers and just going a little bit faster, this oxygen would be -2, and there's 7 of them. So -14, we need that. So chromium has to be +6. This iron is +2, hydrogen's +1. This chromium is +3, iron +3, and then we have +1 and -2. So with balancing with oxidation numbers, we would notice chromium is going from 6 to +3. That's an exchange of 3 electrons, but there's 2 atoms, so times 2, so a total of 6 electrons. Now iron is going from +2 to +3, so that's an exchange of 1 electron. So to make that the same in terms of electrons, we would multiply the Fe2 positive ion by 6. Right, because then we would have an exchange of 6 electrons for both. And once you've done that, now we can just balance the rest by inspection. And doing that, we would put a 2 here, a 6 here, and I believe a 7 in front of the water, which would make 14 hydrogens. And I will put the 14 here. And so then the answer that matches is the one that's already highlighted, and that one was C. Okay, so looking at this next one, we do have our voltaic cell. And when you're taking a look at it, we have a carbon, which is an inner electrode. So if we wrote everything we have, so I have carbon there, but it won't be part of the reaction. You have KMNO4, which you can split up into its ions, so positive and negative. You have, it says it's acidified, so you have hydrogen positive. You have Mn2 positive in solution. And then in the other cup, you have copper solid, copper sulfate, so you have copper 2 positive ions and sulfate ions, and you would also have water present. Now looking at that, all I really need to realize right away is that the MnO4 and the hydrogen ion is my strongest oxidizing agent, right? If I looked at page 7 of the data booklet, that's one I would find first. So that would mean if I'm undergoing oxidation, if I'm an oxidizing agent, I'm undergoing reduction. And if you're undergoing reduction, that happens at the cathode. So that means that this part here with carbon, that is the cathode. And that is what I need to know, because then if I go through my options here, A says electrons flow from the copper electrode to the carbon electrode. That is going to be true because copper would be your anode, and electrons always flow from your anode to the cathode. So it looks like here our answer is A, but we can double check the rest. In B, it says cations migrate towards the copper electrode. Well, that's not true because cations will move towards the cathode, and that would be the carbon electrode. C, about the concentration of sulfate ions decreasing. That is not true, as this copper sulfate solution breaks apart. We'll have sulfate actually would just stay constant. It's the copper's ions that would change. And then the last one about anions migrating towards the copper electrode. That is not true. They would be going, oh my goodness, carbon. They would be going to the copper electrode. Okay. Now this next one is good in terms of knowing the difference between quantitative and qualitative. So with this, it's asking about a redox titration being whether it's qualitative or quantitative. If you are doing an experiment, that falls under quantitative. So it is a quantitative process. And if it is a redox titration, you are looking for an oxidation reduction reaction. So your answer would be B. The next one, which of the following substances is not a common reagent in a redox titration? So if you've done the redox unit, this I think is more just from experiments and just getting that experience with these type of questions. And you will see iodine come up quite a bit. You'll see potassium dichromate. You'll see permanganate. So when I first saw this question, I did take a guess, and that was going to be sodium chloride. is one that you don't see that often. The other part you can take a look at is if you did look at the sodium ion and the chlorine ion, they both are very weak OAs and RAs. So the fact that they are so weak, they probably wouldn't be reacting. So I think that would be another way you could look at that question. Now, the next one about manganese 4 oxide reacting with hydrochloric acid to produce the products. We have that balanced equation, and then it's asking what is going to act as a reducing agent. So if you're a reducing agent, you are undergoing oxidation and you would be losing electrons. So when we're taking a look at that and seeing what would be losing electrons, again, you can assign oxidation numbers here. So if I put -2 for oxygen, which would make Mn +4, then chlorine would be -1, hydrogen is +1. On this side, -1, Mn would be +2. With chlorine would be 0 by itself, and then this last one, -2 and +1. So again, I'm looking for what's losing electrons, so I want to find what is changing and becoming more positive. And what I have changing is Mn going from +4 to +2. That would be the opposite, it's gaining. And then you have chlorine going from -1 to 0. That would be losing electrons because you're becoming more positive. So the species that is undergoing oxidation, that is your reducing agent, would be the hydrochloric acid. This next one, this one, again, it's highlighted here, but just to go over it, which is the following statements about the use of electricity in both voltaic and electrolytic. So we just talked about that one in a previous question. Voltaic cells use chemical energy to produce electrical, and electrolytic cells use electricity to produce chemical energy, and that's why the answer is B. This next one is balancing in acidic conditions. So you would have Cr2O7 with a charge, or charge of -2, and chromium 3 positive here. So if you're balancing in acidic conditions, there are a series of steps you want to follow. The first step being balance any atom other than oxygen or hydrogen. So we'll do that by adding in a 2. Then you want to balance out oxygens by adding in water. So if you have 7 oxygens on the left-hand side, we will add in 7 water molecules on the right-hand side. After that, we add in hydrogens to balance out the hydrogens that were added in for water. So if there's 7 times 2 gives you 14, we will put 14 hydrogen ions on the left-hand side. Now your last step is about charges. So right now with 14 hydrogen ions and this -2 charge, you have a net charge of +12. On the right-hand side, with this 2 in front of the chromate ion and a charge of +3, you have a net charge of +6 because water doesn't have a charge. So to make that the same, we're going to add 6 electrons to the left-hand side. Because if we add a -6 here, you also get +6. So that is our goal, is to make the charge on each side the same. They don't need to equal 0. And then the answer that matches that would be D. Okay, and this next one in the reduction of the reaction that we're seeing here, what are the values? So with this question, I did split it up to be 2 half reactions and see what's related. So Fe3 positive turning into Fe2 positive. For this to happen, an electron would have to be on the left-hand side. And then for tin 2 positive to turn into tin 4 positive, we'd have to have 2 electrons on the right-hand side. So before we can add our 2 half reactions, we have to balance out those electrons, and then we can add everything together. And when you do that, you will see that you'd have a 2, actually let's just write this out. We'd have 2 Fe3 positive plus Sn2 positive to give you 2 Fe2 positive plus just Sn4 positive. So the coefficients would be 2, 1, 2, 1. So the answer was D. And looking at, I believe this is no, not quite our last one, but this one here, looking at this question with the two half reactions and saying that they're being prepared in an acidic solution and wanting to know those two half reactions once it's balanced. Then what we have, so that first half reaction we don't need to do anything for. Sorry, my one dog is barking away in the background. And that second half reaction, we need to balance in acidic conditions. So following those same rules, so this should be an arrow, we're going to add in 2 water molecules to balance out oxygen. So the reason why I put it on the right is because I already had 3 on the left, and I have 1 oxygen from the NO, and now with the 2 water, now I have a total of 3. Now I'll add in 4 hydrogens on the left-hand side, and lastly, adding in my electrons, I would have to add, so I'd have 4 here. I would need 3 electrons to make this balanced. Now, before I can add my half reactions together to get to my total reaction, I will need to multiply my first reaction by 3 and my second reaction by 2 so that I can get a total of 6 electrons being transferred. And then the reaction that shows that is D once you add it together. Now this next one, a chemical reaction is considered a redox reaction if, and this one is all about the exchange of a reaction of electrons. So yes, electrons do need to be lost, but that's not it. Electrons also have to be gained, but that's not it. It doesn't need to be spontaneous. It could be non-spontaneous. So the last one, electrons are lost by one atom and gained by another. That is definitely your answer, because not only can you lose, you also have to gain electrons for it to be a redox reaction. Now this last question is showing that we know how an electrolytic cell works. So electrolytic is when you have to add in the energy to make that reaction take place. So definitely it's going to have a negative cell potential. So 2 is our first part. It is not spontaneous. Cations do not migrate towards the anode. It is non-spontaneous. Electrons travel from anode to cathode. That is always true. And number 7, electrical energy, the energy we put in, is pushing that chemical reaction. So that is also true. As always, I hope you found this helpful. If you did, please subscribe. And if there's any other video I can ever do for you, just let me know in the comments. Thank you for watching.